Hello again, Algebra 2. Here is the second video for Chapter 4, Section 2. Like I mentioned in the first video, it is super short because very similar concept, just a little bit of an estimation piece now. Like we saw in the last video, and I'll show the note again, we have already dealt with what if the x-intercepts are nice integer numbers. They fall very nicely. We see them on our chart. We actually get the 0 that we want. But that doesn't always happen. Not all quadratics behave like that. So let's take a look at this one for example. It's already graphed for us, and we're going to graph one ourselves down below for a second. But take a look here. I see it's not crossing at nice integer x-intercepts. I see that it's between 0 and -1. I see it's between 2 and 3, but it's not crossing nicely at any of those. So what we're going to do is estimate, and really all we're going to say is where it is between, and it kind of details that right here in this little line. The x-intercepts of the graph are between 2 and 3 and between 0 and -1. So give me a statement like that. Tell me between these numbers, between these numbers. You want to make sure you're picking x values as you're graphing that are right next to each other so you can estimate well. And the closer the numbers are together, the better your estimate is. So if you want to do like half increments, you could. You don't have to make just a fine enough estimate, but there you go. So let's take a look at number 2. Down on this page here, I picked number 2 because it is a little bit more challenging because of the fractions. You could go for decimals if you wanted to, but again, we're trying to estimate the zeros if they're not nice integer zeros. So let's take a look. First thing we need to do is make sure it is set equal to 0. Set equal to 0, which it is, life is good. So now I'm going to graph the resulting quadratic function. Already set equal to 0, so I'm going to use this piece here. -1/2 x squared plus x plus 5/2. There we go. For the purposes of my calculations here, to make it go a little quicker, I do have my calculator over here, and I am going to consider, for purposes of my calculator, this as 0.5 and this as 2.5. It's just easier to do decimals on that calculator. So, first step is the vertex. My x value of the vertex is -b/2a, which is -1 over 2 times -0.5, which is -1 over -1, which is just +1. How nice. And then the y value is f of 1. So the function value at the x value that we just found. So I'm going to have 1 squared is 1, so I'm going to have -1/2 plus 1 plus 2.5. That is going to give me -0.5 plus 3.5, so I have 3. So I have my vertex at 1, 3. There we go. So 1, 3, there we go. And we know that this is a parabola that is opening downward. It has a maximum value because the a value is -1/2. So on my xy table here, I need to again make sure that I pick numbers that are wide enough, like along far enough, that I cross over the x-axis. So I'm going to give myself a couple more here just in case. I already know 1, 3. Let's go for 2, 3, and 4 and see what happens. And again, those are going to be symmetric to 0, -1, and -2. So into my handy dandy calculator, I want to plug in 2 into the function value here. So I'm going to have -0.5 times 2 squared. Remember to put the parentheses around the number and then square it. It's not such a big deal here because it is positive, but especially if you're dealing with negatives, make sure that it is in parentheses first before you square it. Then I need to add 2, then I need to add 5/2, which is 2.5. So I get 2.5. How fun. Then I'm going to plug in 3, so I get -0.5 times 3 squared plus x, which is 3, plus 5/2, which is just 1. Good thing I picked a couple more. Notice I'm not quite down to 0 yet. Okay, then I plug in 4, and I have -0.5 times 4 squared plus 4 plus 2.5. Ah, notice I finally crossed down into the negatives. And here's a good tip. You'll know you have found the zero, or at least the estimate of the zero, when you go from positive to negative, or vice versa. When you make that crossover, you know that there is a zero in here somewhere. So that's our estimate right there. So really, we don't need to graph it at this point, but we're going to just to make sure that it looks correct. Again, we know the parabola should look like an upside down U. Oftentimes, as folks are plugging in the x values and getting out the y values, they make a couple mistakes, just some maybe sign errors along the way in your calculator, or squaring the negative in an incorrect way, things like that. So graphing it is a good way to check to make sure your points make sense. Make sure they're going down in a cascade like they're supposed to. So let's graph these to make sure it all looks good. I have 1, 3. I have 2, 2.5 in between there. 3, 1, 4, negative 1.5. And now I need to be symmetric over my axis of symmetry coming out of the vertex there. So I have, again, 1 block to the right. I'm going to go 1 block to the left, same height. 2 blocks to the right. I'm going to go 2 blocks to the left. 3 blocks right. I'm going to go 3 blocks left. And there's my parabola. And now for the final answer, we want to do a combination of what my chart says and what my graph says. Because again, sometimes we draw like a thicker line, so maybe it would look like my line is hitting at 2. So combination of what you see and this graph here, the chart here. First off, I see that I get the shape that I knew I was supposed to have. I'm supposed to have this upside down parabola, and I see that. So I know that my points are in line, which is good. Now, as far as my solutions, it says, solve the equations. If exact roots cannot be found, state the consecutive integers between which the roots are located, which is what I have to do here because I don't have exact zeros. So I'm going to say for my final answer, my solutions are between, first one are between -2 and -1, and between 1, 2, 3, and 4. And that's all you have to say. That's all you need. I just need to see your XY table, show me your graph, make sure the points make sense, and write out your final solution for me. That's all I need. So if we have nice whole numbers, that's great. If we don't, that's fine too. We're going to learn later in this chapter about how we know more specifically what these are. But today is not that day. We will get there. For now, just estimate for me. There we go. So, there we have it. Chapter 4, Section 2, all about solving quadratic equations by graphing whether they're integer numbers or we have to estimate. There we go. And we'll continue talking about all of this in class.